Lesson 1-7 is on functions. In this video, you will learn to determine whether a relation is a function and find function values. Vocabulary for this section includes function, discrete function, continuous function, vertical line test, function notation, and nonlinear function. Okay, so what is a function? A function is a relation in which each element of the domain is paired with exactly one element in the range. So if we look here, -3 goes to exactly one value in the range. It doesn't go to 2. Okay, and 0, same thing, 2 and 4. Okay, so we want to look at this and say whether it's a function or not and explain it. So does each thing in the domain go to only one thing in the range? Looking at this, we can say yes. Nothing in the domain goes to two things within the range, or two or more. So it's a function. If I look here and I want to determine if this is a function, my domain, -7 only goes to -12. -4 only goes to -9, 2 only to 3, and 5 only to 0. So this one is yes, it is a function because each element in the domain goes to only one element in the range. So you guys look at these and say if they are functions. Be careful on this one with things that appear twice in the thing. So here, this one, and this one. Be careful with those. Okay. Example 2. There are 3 lunch periods at school. During the first lunch period, 352 students eat. During the second lunch period, 304 students eat. During the third period, 391 students eat. Make a table showing the number of students for each of the 3 lunch periods. So we can say period here, and then this one's going to be the number of students. And we can make a table. So for first period, we have 352. For second period, 304. And for third period, 391. Okay, so I would be making a table from this information. Okay, determine the domain and range of this function. So my domain, remember, is this number here. It's usually the independent variable, or it is the independent variable. So in this case, it's the periods. So our domain is 1, 2, and 3. And our range is 352, 304, and 391. Now, it's not wrong to write it like this, but a lot of times when people write domain and range, they write them in order. So they would say 304, 352, and then 391. Okay, so it's not wrong to have it the first way, but it's more proper to have it in order. Okay, part C, write the data as a set of ordered pairs, then draw the graph. So if I were to make a set of ordered pairs, I would do 1, 352, 2, 304, and 3, 391. Okay, and the way you would do this is you would, have 1, 2, 3 on the x-axis because it's our independent variable, our domain, which goes on the x, and then our range is going to go on the y. So I can say this is like 3, we'll do a squiggly line saying there's more there. We'll say 350, 360, 370, 380, 390, and 400. And you would plot the points. So 1, 352 would be about here. 2, 304. Oops, I didn't make this small enough. It would be somewhere down there. And 391 would be like up here. So because my graph is so bad, you guys can look at this one. So you have the point 1, 351, 2, 304, was it? and then 3, 391 is that last point up there. Okay. All right, part D, it says state whether the function is discrete or continuous. So now because we have dots and this is not, these are not connected, this is called discrete. If I had graphed something and had gotten like a line, that would be continuous. So discrete, not connected, continuous, smooth, connected line. Okay, so in this case, this is discrete, discrete. Because they are dots. It's scatter plot, basically. Okay, so you guys do this one. Example 3, determine whether x equals -2 is a function. So whenever you have just a variable like x or y equal to a number, that means it's going to be a straight line. In this case, x equals 2. So first thing I'm going to do is going to graph this. So I want to know if this is my x-axis and this is my y-axis. I want to show for all values when x is equal to -2. So if this is -2 here, anywhere along here, any point on this line is going to give me an x value of -2 because anywhere along here, this point here, if you think about this as the point -2, 2, that point there has x -2. If I were to pick a point here, this is the point -2, 0. So it also has an x value of -2. If I come down here and say this is the point -2, -3, this point also has a -2 x value. So all of these have -2 as x. That's why that's the graph of x equals -2, because anywhere on that line, whatever point you pick, the x value is going to be -2. So if I want to see if this is a function or not, we're going to use something called the vertical line test. So what we do is if we were to draw a vertical line anywhere on this graph, if I hit the point, more than one point on the line that's drawn, it's not a function. So here, if I were to draw a line here, I hit all of that point. So if I'm looking at something more like this, if I have a point here, because those 2 points have the same x value, that means that it doesn't pass the vertical line test. However, if I have something like this does pass the vertical line test because no vertical line I draw is going to hit more than one point. If I have a line that looks like this would be a function because anywhere I draw a vertical line, it will not hit more than once, so it passes the vertical line test. If I had something like this would not pass the vertical line test because I can draw a vertical line, maybe more vertical, and I would hit that line I originally drew more than once, but that's not a function. So not a function, 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 not a function. Okay, so in our case here in this example, this is not a function because it hits the line infinitely many times. Okay, so you guys determine if this is a function using the vertical line test. Okay, so summary, we have tables, mapping, equations, and graphs. Those are all different ways to represent the same, well, more or less the same concepts. Okay, these are different ways to represent functions. Okay, so now we're going to look at function values. So if you're not familiar with function notation, what this is saying, the name of this function is f. And it's saying, okay, I'm going to take my function that I have named x, where my variable is x. This is not f times x. Do not confuse that. So this is my function f, where my variable is x. So what this is saying, if I go into my function f, when my variable is equal to 4, that means I'm going to put 4 in for the variable in my function f. So that means I'm going to do f of 4 is going to be 3 times 4 minus 4. Okay, this is just my notation. I do not multiply this. I just leave it like that. That's all I'm looking for. This I don't do anything with. I leave it. Okay, so 3 times 4 is 12 minus 4. and 12 minus 4 is 8. So that means that f of 4, when I put 4 into my function f, I get 8, is what that is saying. Okay, so if I were to do this, so what this is saying, remember, f is the name of my function, x is my variable. So what this is saying when it says find f of negative 5, it's saying when I put in negative 5 into my function f, what do I get? So this is what f of x is equal to. That's where I'm going to put in the negative 5, where the x is. So this is going to be 3 times negative 5 minus 4. So I get negative 15 minus 4, and I get negative 19. So that means when I put in negative 5 into my function f, I get negative 19. And this is your answer. Okay, remember, we don't do anything with this over here. Okay, you guys try this one. Okay, last thing we want to do is when we have a little bit more complex. So this now, the name of my function is h, my variable is t. So when I say h of 3, it's saying, okay, what do I get for my function h when I put in 3 for its variable, which is t? So I'm putting in 3 for that t, just on that one side, not on the side that has this. Okay, so I do minus 160 times 3 plus 16 times 3 squared. So now what I'm going to do is simplify this. Okay, so I do 3 times 160 and I get 480. And I do 3 squared, which is 9 times 16, and I get 144. So the last thing I want to do is just add all of these up, or do this. So I'm going to do 1248 minus 480 plus 144, and I should get 912. So this one is equal to 912. Okay, the next thing, what if I have a variable within what I'm looking for? That still means I'm putting in 2z. It's saying, what is the value of h when I put in 2z for its variable, which is still t? So now I'm just putting in 2z everywhere I see a t. So it's going to be 1,248 minus 160 times 2z. I'm replacing the t with that whole thing. And I always put it in parentheses just to be sure I know how I'm doing it. All right, and then I do 16 times 2z squared. Okay, and then we're going to go through and simplify this. So it's going to be 1,248 minus 320z. And this becomes 4, right? So I square this whole thing. So this becomes 16 plus 4z squared if I square both the 2 and the z. So now I'm doing 16 times 4, and I get 64. So this is 1248 minus 320z plus 64z squared. Now I cannot combine this anymore because this doesn't have a z, this has a z to the first, this has z to the squared. So none of them are like terms. So I can say that's the end, and that means h of 2z is equal to this. So when I put 2z in for my variable in h, I get this. Okay, and that's the end. All right, so you guys find h2 and h of 3z. And that's the end of lesson 1-7.